Hello, good morning student. How are you? I hope you all are happy, healthy and fine at home. So what did we discuss yesterday? Yesterday we discussed about the alpha amino acid, how they are naturally present or how the peptide synthesis is carried out by using the alpha amino acid, and except the glycine is a achiral carbon atom, and rest of there are 20 amino acids. Out of that 20 amino acid, first one, that is a glycine, is a achiral in nature. Achiral means it is optically inactive in nature, and rest of the 19 amino acid, they are chiral amino acid, and they are the optically active in nature, and they are present in the L configuration. As we know that D and L is used as a relative configuration. These are the nomenclature systems specially designed for carbohydrates and the amino acids. And as we know that all carbohydrates are present in a D form, whereas all the amino acids are present in the L, capital L form. When NH2 group is on the compounds generally represented according to as a Fisher projection formula, and observe the structure. When that NH2 group is present on the left hand side, that is designated by the L, and all these amino acids are generally has S configuration. S and the R are the absolute configuration, and they generally all the glycerine, all these amino acids are found to be L configuration or the S configuration. That are the thing we have discussed yesterday. Today, what we are going to discuss today? Today we are going to discuss the protection and deprotection used for the synthesis of peptide synthesis. How peptide synthesis is carried out in the laboratory or in the naturally, how the peptide bond is formed or peptide linkage, that is a secondary amide type of the compound, the bond is formed, that is there. Now we are going to learn the general peptide is what type of the general peptide. As we know that general peptide is the general peptide is like this. Let us see here. And as we know that in the amino acid there are the peptide are synthesized, the starting material used for the synthesis of peptide is the amino acid. As we know that is the starting material, or these are the substrate. Let us see, suppose we have a one H2N, then CH, let us see here R1, then COOH, that is a carboxylic group. This is a general amino acid, one of the amino acid. There are 20 amino acids. So let us see, this is a one of the amino acid, H2N, CH, R1, C double bond O. By changing the nature of R, we are getting as a different type of the amino acids. Now this will be treated with another amino acid, H2N, then CH, R2, COOH, then what are you going to get here? That we are talking about general peptide is it is a peptide synthesis. And as we know that this peptide undergoes as a condensation reaction, or general before that the general peptide is like this, NH, then CH. Let us see, first one is a general peptide. In this case, suppose here NH, then CH, let us see here R1, then C double bond O, then NH, then CH, R2, then R2, then C double bond O, NH, then let it be CH, R3, then C double bond O, then you can call it. So let us see, this is a general peptide. This is the general peptide, and now here look at this bond clearly here. The bond adjacent to carbonyl group and NH2 group, that is a amide. So this is called as a peptide bond. This one is known as a peptide bond, or we can call it as a peptide linkage. This one is also known as a peptide linkage. Peptide linkage. This is a peptide linkage. Look at here also. There is a NH2 C double bond O NH group, and now in this common thing, what do you see? This NH, this we can call it as a N terminal. This we can call it as a N terminal, and this side, on a right hand side, there is a carbon atom, and therefore you can call it as a C terminal. C terminal. This is a C terminal. So this is the general peptide looks like this. NHCHR1 C double bond ONH, again CHR2 C double bond ONH, then CHR3 C double bond O, like this. So this one is called as a N terminal, whereas this side is called as a C terminal. So there are two terminal, N terminal always on a left hand side, and C terminal you can show always on a right hand side. So these are the terminals. Now condensation of two amino acids leads to the formation of four different products. What I said just now, condensation of two amino acids leads to the formation of four different products. How we are getting these four different products? Let us see here. Generally, we are considering here the two different amino acid. Let us see here. Just here H2N, then CH, R1, then C double bond O, OH. We can write this carbonyl group so that we can understood how the reactions are taking place. Now let us see another one. Here H2N, then CH, R2, C double bond O, and OH, right? This you imagine, suppose this is a one amino acid, this is another amino acid. In a amino acid, we know that there are two functional groups are present. One is a carboxylic group, one is a amino group. Here carboxylic group, this is a amino group, right? Now R1, suppose if you take as a H here, you will get glycine. If you substitute R is equal to methyl group, you will get as a alanine, right? When these two combine together, if you combine together, there are the reactive functional group. And as we know that among these two functional group, one is a carboxylic group, another one is a amino group. Which one do you think is a more reactive in nature? Here the amino group is a more reactive over the carboxylic group, because nitrogen containing lone pair of electron, and it has the ability to donate the electron, and therefore the reactivity of that amino group is a greater as compared to the hydroxyl group, which is present in the carboxylic group. here the oxygen atom is more electronegative than the nitrogen atom, and therefore it hold the electron tightly on it. Therefore the nitro group is a more nitro group is a readily donate the electron, and that therefore it is a more basic in nature. Now after the condensation, let us see here condensation. Condensation, what do you get here? After the condensation, you might have heard condensation means there is a formation of the new bond, covalent bond is formed between here carbon and the nitrogen atom. Condensation took place. How? Let us see here. OH from here, the OH from here, and one remember here H. I am for sake of convenience to show the clarity. Condensation means there is a removal of water molecule takes place over here. OH from carboxylic group and H from this nitrogen, and the bond is formed between this carbonyl carbon and the amino nitrogen over here, and condensation took place. When this happens, you are going to get first one, there is a cross condensation takes place over here. First, look, one of this amino acid condense with another amino acid. What do you get here? Here you are going to get H2NCH. Let us see here R1, then C double bond O, then NH. This peptide bond is formed CH, R2 and C double bond O, OH. NH2 group is free, carbonyl group is free, and this bond is formed, that is nothing but as a peptide bond, or it is known as a peptide linkage, one of this molecule. Now another molecule will be formed like this. Here H2N, then CH, R2, then C double bond O, NH, CH, R1, then C double bond O and OH. Look at this. Here also peptide bond is formed. The peptide bond is nothing but as a C double bond O NH. This is called as a peptide bond. Now here, look at here adjacent to R1, NH2, amino group is a free, and R2 there is a carboxylic group is free. But in another condensation, another product, what do you see? Adjacent to the R2 there is a NH2 group is NH2 group is free, and R1 there is a carboxylic group is free, and therefore these two products are completely different from each other, and therefore this type of the condensation is known as cross condensation product. This is called as cross condensation product. Cross condensation product. This cross condensation product, right? This is a cross condensation product. One of that NH2 group and carboxylic group, they condense together, we are getting this product. Another COH of this group and NH2 of this another amino acid condensed together, we are getting this type of the product, and this type of the condensation are known as cross condensation, right? This is a cross condensation. When this molecule itself get condensed with this, so what do you get here? H2N, then CH, R1, then C double bond O, then NH, CH, R1, C double bond O, then OH. This type of, there is again as a peptide bond formation, two amino acid get condensed together. This amino acid get condensed with another molecule of this amino acid, and we are getting as this type of the product. Another one, what we get here, H2N, then CH2, then C double bond O, NH, then CH2, then C double bond O, OH, right? This is the first one, this is the second one, and this type of the condensation are known as self-condensation. These two products are known as self-condensation. These are known as self-condensation. Self-condensation. These two are known as self-condensation. These two are known as cross-condensation. Here R1 and R2. Look at here R2 and R1. Here R1, R2. Here again R2 and R2. And therefore this type of the condensation is known as self-condensation. Means when two amino acid condense together leads to the four different product, right? Formation of the four different product. Condensation of the two amino acids leads to the formation of four different products, and these are the four different products we have shown here. In this case, what is happening here? Such synthesis is not useful. This synthesis is not useful because there is a this product, lot of products we are getting, and there is a large difficulty we can face for separation. We cannot separate this compound, all are the mixtures are there, and therefore we can face lot of difficulty as far as getting the single compound, and therefore this type of the synthesis is not useful at all. And to avoid the formation of mixture of product, number of mixture of product, planned synthesis carried out. To avoid such a type of the mixture of the product, control, or what we can call it as a planned synthesis is carried out. Means what is the main application of what I am trying to explain here. If we directly condense two amino acids, we are getting such type of the mixtures are there, and there is a lot of difficulty in a separation. To avoid such a type of the mixture, planned synthesis is carried out in the laboratory, and so that for that purpose you can protect the either amino acid or the carboxylic acid of one of the group by using as a suitable protecting group. And so far we have learned what are the protecting and deprotecting group can be used for this protecting for this functional group, so that we can get the desired product. And therefore controlled peptide synthesis is carried out in the following steps. And there are now to avoid such type of the synthesis, the planned synthesis is carried out for the peptide synthesis. Now let us look at that one for the peptide synthesis, how the controlled reaction, controlled synthesis is carried out to avoid the mixture of the product, because when we are getting as a mixture of product, we cannot get the pure compound in a separate, and therefore planned synthesis is carried out in the laboratory so that we can get the single product in a pure form, higher yielding, and therefore first one, controlled peptide synthesis is carried out in the following steps. Controlled peptide synthesis carried out in the following step. Let us see step number first. Step number first is called as the protection of COH group of 1-alpha amino acid. Protection of COH group. Now is a protection of COOH group, protection of COOH group, protection of COH group of 1-alpha amino acid, protection of COH group of 1-alpha amino acid. Let us see here general, as we know that the general structure of amino acid H2N, then CH, R1, then C double bond O, OH, then this compound can be treated with some suitable protecting group so that we can get this H2N, then CH, R1, C double bond O, and what we did, we protected the carboxylic group. This is the protection of carboxylic group. Protection we carried out here by using as a suitable reagent that we already seen. Then number 2, protection of NH2 group. Step number second, protection of NH2 group, protection of NH2 group of second alpha amino acid, and activation of COH group, and activation of COOH group, activation of COH group of same alpha amino acid, So that is a second step we have carried out here, protection of NH2 group of second alpha amino acid and activation of COH group of same alpha amino acid. In the first step, what we have done, we protected the carboxylic group of 1-alpha amino acid. In the second step, what we have done, protection of amino group of second alpha amino acid and activation of COH group of same alpha amino acid. What do you get over here? Same general formula, R, N, then CH, R1, then C double bond O, then OH. This is another molecule you consider over here. Now here we are protecting the amino group, and the protecting group we already learned in our previous lectures. The protecting group used for amino acid, as we know that benzyl ester, or what we benzyl chloride, or what we can call it as then CBZ, BOC, FMOC. These are the some of the suitable protecting group. By using that protecting group, we can protect that NH2 group. When we are protecting that NH2 group, the reactivity of that, the reactivity or the activity of that NH2 group is get decreased, so that, and we can carry out the reaction on the other center of the reaction center to get the desired product. And for that purpose, here what we are doing here let us see here Z, NH, then CH, R, then C double bond O, and then here we are using as X. Let us see here X, right? And this part, what we have done, we protected the amino group over here. Protected amino group, right? Protection of amino group. And in this case, what do you see over here? Activation. This we can call it the activation. We activated that carboxylic group, because the reactivity of carboxylic group is less. When it is converted into as acetyl chloride, that carbonyl carbon becomes as a more electro deficient in nature, and the nucleophilic substitution reaction can be easily carried out at that center, and we will get the desired product in this case. So what we did in the second step, protection of NH2 group of second alpha amino acid and activation of COH group of same alpha amino acid, and this part is a protection of that amino group, and there is a activation of carboxylic group. That is a second step we carried out here. Now let us look at as a third step here. Third step, what is the third step? We are going to carry it out here, condensation of both alpha amino acid. Third one, condensation of both alpha amino acids. Condensation of both alpha amino acids. Let us see here condensation of both alpha amino acid. As we know that this one, what we here Z, then NH, CH, R1, here you can consider R1, then C double bond O, X is activated over here, and now it will be treated with first one, this H2N, then what is that? H2N, then CH, R2 you can call it as this one, R2, then C double bond O, and here will be the Y, right? Here will be the Y. Means protected here carboxylic group, here the protection of amino group, and there is the activation of this carboxylic group. Now, right? Now let us see here what is going to happen. The condensation reaction is carried out, and we will get the desired product. Now condensation of both alpha amino acids. One of the alpha amino acid we protected NH2 group and activated the carboxylic group. In the first step, what we have done, we protected the carboxylic group. Now here NH2 group is free to attack on this. Specifically, there is only one possibility only. NH2 group is a highly reactive. It is going to attack on that carbonyl group, and there is a condensation reaction takes place here. Condensation reaction takes place, and what you are going to get here, Z NH CH R1 C double bond O, then NH CH R2 C double bond O and Y. This is the product, only and only this product you are going to get when you done this type of the treatment on both the amino acid, the resulting compound. When you resulting compound obtain the desired product here. This is the desired product we are getting here, right? So in the step number first, what we did, protection of the COH group of 1 alpha amino acid. Then in the second step, what we did, protection of NH2 group of second alpha amino acid and activation of COH group of same alpha amino acid, and we got protection and the protection and the activation of carboxylic group and protection for NH2 group. In the third step, what we did, condensation of both the alpha amino acids are carried out, and we are getting the desired peptide synthesis, and this bond is formed is a peptide bond. And now this is a 2 amino acid we condense together, we got one peptide bond formation. Now next step will be the deprotection. Step number 4th is a deprotection. Step number 4th one is a deprotection, and deprotection is a very, very essential, because we have to get the protected group back as its original state, and therefore deprotection will be carried out here, and we will get the by using a suitable reagent, deprotection can be carried out. And what do you get over here for this? This is a product we got here, Z NH CH R1, then C double bond O, NH, then CH R2 C double bond O. Here why? By using as a suitable deprotection group, what do you get? NH2 group get free over here, NH, then CH R1 C double bond O, then NH CH R2 C double bond O and OH. Look at here, deprotection. After the deprotection, whatever N terminal and C terminal, at N terminal there is an amino group we got here, and in C terminal there will be a carboxylic group. Then again same treatment you can carry it out over here, protection of the amino group and the activation of this one, and treat with the this compound, you will get the peptide synthesis. So in this way you can increase the peptide from N terminal and not from a C terminal if COH group is activated. Let us see here, always remember, increase the peptide synthesis, increase the peptide from N terminal and not from the C terminal. If COH group is activated for further linking, then racemization occurs. Then what is going to happen? Racemization, as we know that racemization means what? Racemization means mixture of the enantiomers. Enantiomer means what? They are non-superimposable mirror images of each other. One is rotating the plane of polarization to right hand side, another will rotate the plane of polarization to the left hand side, and that type of the mixture is called as a racemic mixture. And to avoid the let us see how the racemization occur over here. For example, how the racemization is occur over here. Let us see here. For example, suppose we have this compound. Let us see here, general NH, then CH, R1, then C double bond O, then here NH, then C. Let us see hydrogen atom over here, and this one is R2. As we know that this is R1, this is R2, and then here C double bond O and X. This is activated, right? Now when it is treated with a base will abstract the proton from here, and this form as a double bond over here, and this carbonyl group is going to attack on this carbonyl group, this around it, and get eliminated. The base is used in this case, base, and we are going to get here this one NH, CH, R1, then there is a C double bond N, then here O, then C double bond O, then C. Let us see here hydrogen atom, and this is a R2 over here, right? This is a compound we are getting. That compound is known as oxazolone. This is known as a oxazolone. The name of this compound is a oxazolone. And now in this case, what then again base is used here. After using as a base, this type of the things happening, this form as a double bond, negative charge on it, and we are going to get racemic mixture here. This one NH as it is, CH, R1, then C double bond N, O, then this C double bond, then O. Let us see here, there is a let me draw this clearly here. Now what is happening here? NH, then C, CH, R1, then this C double bond N, then O, then C. Let us see here, this C form double bond here, O minus, and this R2, right? And this is called as racemization. It's known as a racemization, and further it will be converted into this one, this negative charge from over there, this one, and you are going to get the mixture like this. There NH, then CH, R1, this one, then C double bond N, here is a O, then C double bond O, there C single bond. Now here look at here R2, and now this hydrogen atom comes on above. Here is a hydrogen atom below the plane, here hydrogen atom is above the plane. That type of the racemization occurs over there, and after the hydrolysis, and after this hydrolysis, what do you get? You are going to get DL, you are going to get DL products, DL products, DL products we are going to get here. And as we know that D product is useless. In this case, the D product is useless. Here, the D product is useless. D product is useless over here. D product is useless. D product is useless, and only L is useful. D product is useless, only L product is useful. Only L product is useful, and stepwise synthesis will avoid the racemization and do not activate C terminal in peptide synthesis. I think with this let us stop today here. Remaining we will see in the next lecture how racemization is controlled during the peptide synthesis, or how racemization occurs during the peptide synthesis. That we will see in the next lecture. Let us wrap up the lecture here. Thank you. Have a nice day.